In the world of software, speed is everything. And today, we're going to break down a story that might just redefine what we think is possible, showing how one team built a massive, global app in record time.
28. That's the number you see here, just 28 days. That is the total time it took a tiny team of engineers to take a major app from a simple idea all the way to a full-scale production launch.
So the big question is, how on earth did they pull that off? Just 4 engineers. The answer involves a brand new kind of collaboration, and honestly, it has huge implications for how pretty much all software could be built in the future.
Okay, so let's set the scene. The story kicks off with the Sora app. You know, the tool that turns text into video. It was a massive, massive hit on iOS. And that success created this incredible pressure to get an Android version out the door fast. The clock was seriously ticking.
Now, the old way of doing things, you just throw more engineers at the problem. But we all know that often just creates more chaos, more meetings, more complexity. It actually slows you down. So they needed a totally different strategy to move at lightning speed.
And that's where things get really interesting. See, instead of adding more people, they decided to scale their abilities by adding a powerful new kind of teammate, an AI coding agent named Codex.
But here's the real genius of their approach. They didn't treat the AI like some fancy autocomplete tool. No, they treated it like a brand new senior engineer who just joined the team. Someone who's incredibly skilled, but still needs clear direction to understand the team's goals and its standards.
Their whole success really hinged on understanding this new teammate's role. They had to figure out where it excelled, and just as importantly, where it needed a human to step in and provide that critical judgment. It was all about making the partnership work.
On the one hand, Codex was an absolute powerhouse. I mean, it could read and understand massive code bases almost instantly. It was amazing at writing tests, the kind of work engineers sometimes drag their feet on, and it could even come up with totally new solutions that the human team just wouldn't have had time to think of. But, and this is a big but, it also had some pretty significant blind spots. The AI had no idea if a feature felt right to a user. It didn't have that deep architectural judgment, so it would often go for a quick fix instead of the right long-term solution. It needed that human guidance on how to build things the right way.
So how do you manage that? How do you get the best of both worlds? Well, they created a very specific playbook, a workflow designed to get the absolute most out of both the human engineers and their new AI teammates.
The whole process basically boiled down to this one simple philosophy. Humans set the strategy and the quality bar, and the AI handles all the heavy lifting of actually writing the code. It broke down into 4 key steps.
Okay, step 1 was all about the foundation. The human engineers designed the app's core architecture. They built some key features themselves to create a library of examples. This was basically their way of showing the AI, hey, this is how we build things around here. This is our style.
Next up, planning. And this part is absolutely crucial. Before writing a single line of new code for a feature, the team would first collaborate with the AI to generate a super detailed plan. They'd agree on the step-by-step approach before anything actually got built. And with that human-approved plan in place, they could just let the AI run. I mean, it could work unsupervised for hours at a time, just churning out thousands of lines of code that were all perfectly aligned with the team's vision. So you can imagine this new way of working completely flipped the script on the day-to-day job of a human engineer.
There's this famous old saying in software called Brooks' Law. It basically says that adding more people to a project that's already late just adds more communication chaos and actually makes it even later.
But what this team found is that AI totally changes that math. The bottleneck wasn't about the physical act of typing code anymore. The real work, the hard part, shifted to high-level thinking, reviewing plans, making architectural decisions, and integrating what the AI produced. So they spent way less time writing boilerplate code and way more time thinking about the big picture, the user experience, the system design, the overall quality. They weren't just faster coders anymore. They were like conductors leading an entire AI orchestra. All right, so that's the process. But did this new method actually work in the real world? Let's talk about the results, because they are pretty staggering.
In the first 24 hours after launch, 1 million Android users generated over 1 million videos with the app. That is just an incredible display of scale and demand right out of the gate.
And you might be thinking, okay, they built it that fast, it must have been buggy.
Nope. The app was incredibly stable. It achieved a crash-free rate of 99.9%. That's a level of quality you'd expect from a project that took way more people and many more months to build.
And here's the ultimate proof. On launch day, the Sora Android app shot straight to #1 in the Google Play Store. It was a complete and total validation of this new way of working.
Look, this story is way bigger than just one app or one team. What this really is a clear blueprint for a whole new era of software development, an era where human creativity gets amplified by AI execution.
The real takeaway here isn't that AI is going to replace engineers. It's that this kind of human-AI collaboration can multiply their capabilities. It allows these small, super-focused teams to achieve things that, until now, were only possible for massive organizations. And that just leaves us with a really powerful question. What comes next?